Hi everyone, I am Divya Dharshini R, currently in final year pursuing BE in Electronics and Communication at Acharya Institute of Technology, Bangalore. Today I am here to present my internship project washing machine simulator using PIC16F877A microcontroller. So, objectives. The first objective is to develop a washing machine interface that enables user to interact with various washing modes by pressing digital keypads and adjust water levels through long presses. The second objective is to implement a system to display the ongoing function, remaining time, and ensure the machine halts operation upon detecting lid opening, thereby enhancing user safety and convenience. Overview of this presentation. Introduction, few basics of embedded C, and about the microcontroller that we are using in this project, peripherals used, software tools used, functional requirement, and finally the conclusion. Moving ahead with the introduction, embedded systems are specialized computing systems that are designed to perform specific tasks or functions within a larger system. Unlike general purpose computers, which are designed to run a variety of applications, embedded systems are typically built to perform a dedicated function or set of functions. They are often found in everyday devices such as smartphones, digital cameras, household appliances, and automotive systems. So, embedded systems consist of hardware components such as microcontrollers or processors, memory devices, input output interfaces, all of which are designed to work together to form an embedded software. The software, also known as firmware, is typically developed to meet the specific requirement of the embedded system and is often optimized for performance, power consumption, and size. So, one of the key characteristics of embedded system is the real-time operation, meaning they must respond to inputs and events within a specified time frame. This requirement is critical in applications where timing is crucial, such as in automotive system, industrial control system, and medical devices. A washing machine is a common household appliance that automates the process of cleaning clothes. It typically consists of various components, including drum for holding clothes, a motor for agitating the clothes, pumps for water circulation, sensors, for example, sensors like water level sensor, temperature sensors, and control system for managing the washing processes. The control system in a washing machine is an example of an embedded system, as it is responsible for executing tasks such as selecting wash cycles, adjusting water levels and temperatures, and monitoring the operations of the machine. Embedded system plays a crucial role in enhancing the functionality, efficiency, and user experience of washing machine and other household appliances. So we could conclude that overall, embedded system plays a crucial role in modern technology, enabling the functionality of a wide range of devices and systems that we rely in our daily lives. So here we could see the classification or types of embedded system. There are two types based on performance and functional requirement and based on the performance of the microcontroller. So they are subdivided further. So based on performance and functional requirements, there are four types: real-time, standalone, network, and mobile. And based on performance of microcontroller, there are three subdivisions: small scale, medium scale, and sophisticated. So coming to components of embedded system, so we have CPU, sensor, analog to digital conversion, digital to analog conversion, actuators, FPGAs, software, memory, ports, user interface, etc. So here we take the inputs from sensors. The output of the sensor will generally be in digital form. So coming to the components of embedded system, we have CPU, sensors, actuators, ADC, DAC, user interface, ports, software, memory, FPGA, etc. So we take inputs from sensor. The output of the sensor will be generally in a analog form. So it has to be converted into digital form. So we pass that through analog to digital converter. Then it is fed into a microcontroller which we are using. Then it undergoes it performs few operations which we expect and which we give command as. Then the output of the processor is fed to a digital to analog converter, and then we could see the outputs through the actuators. So moving ahead, we're going to see few basics of embedded C programming language. So embedded C is a variant of C programming language that is specifically designed for programming embedded systems. It includes features that make it well suited for embedded application, such as direct access to hardware peripherals fixed with data types and limited or no standard library support. In embedded C, developers often interact directly with hardware registers and memory to control the behavior of the embedded systems. This low level programming approach allows for precise control over the hardware and can result in more efficient code execution. So, embedded C programming requires an understanding of the target hardware, architecture, and specific knowledge of the microcontroller or processor being used. It is widely used in a variety of embedded applications, including consumer electronics, automotive system, industrial automation, and many more. So here we have a comparison between C programming and embedded C programming. So coming to C programming possesses native development in nature, while embedded C programming possesses cross development in nature. So C programming is independent of hardware architecture, but embedded C programming is dependent on hardware architecture, that is microcontroller or any other devices. C programming is used for desktop application, operating system and PC memories, while embedded C programs are used specifically and used for limited resources like RAM, ROM, and IO peripherals on embedded controller. So, coming to data types in C, data types in C are used to define the type of data that a variable can store or hold. They are important because they determine size and layout of variable memory, which affects how the data is interrupted and manipulated by the program. Using the correct data type is crucial for ensuring that variables can store the appropriate range of values and that operations performed on them are done correctly. For example, using a integer data type for a variable that should store floating point number can result in loss of precision. Data types also help make programs more readable and maintainable by providing information about the intended use of variables. For example, using a data type such as char for variable that stores characters makes it clear that the variable is intended to store a textual data. Here we could see the data types in C. There are three. There are main three data types: primary data types, user defined data types, and derived data types. In primary data types, we have four subdivisions: char, float, int, and void. In char, we have two: signed char and unsigned char. Similarly, in float, we have three: float, double, long double. And in int, we have various subdivisions like int, long int, unsigned long int, unsigned long int, short int, unsigned short int. Next, in user defined data types, we have two subdivisions: enum and typedef. Similarly, in derived data types, we have four subdivisions like pointers, arrays, structures, and unions. So, moving ahead to operators in C. So, operators are used in C programming to perform operation on variables and values. They allow you to manipulate data and control the flow of the program. Here, C programming provides a variety of operators, including arithmetic operators, relational operators, logical operators, assignment operators, bitwise operators, and other few. Here we could see relational operator, assignment operator, arithmetic operator, bitwise operator, conditional operator, logical operator, and miscellaneous operators. So conditional statements in C, we have two types, if else and switch. In if else we have four subdivisions, if else, if else if, nested if. If statements are a simple loop where condition is given. If the condition is satisfied, then that loop is executed or it is terminated automatically. So the second is if else. If the condition is satisfied or true, then the particular set of statements are executed or operations are performed. If the condition is not satisfied or false, then the else part is executed. Similarly, in if else if, there are multiple if conditions and else conditions, and it executes accordingly. Nested if defines that a if statement is nested inside another if statement. So in switch statement, we have cases. We have multiple cases where the operations are performed. So coming to the microcontroller which we have used, that is PIC16F877A. So in this internship project, we have used this particular microcontroller. If we see the specification of this microcontroller, the bus width is 8 bits. Pin count, it has total number of 40 pins, and there are 33 pins for input and output. Program memory, 14.3 kilobytes. CPU speed, 5 million instruction per second. RAM size is 368 bytes. EEPROM size is 256 bytes. So going ahead with the architecture of PIC16F877A microcontroller in PIC lab. Here we have GPIOs, I2C protocol or RTC or EEPROM, temperature sensor, and ADC, RS-232, LEDs, buzzers, digital keypads, SSDs, matrix keypads, and the LCD display. So coming to interfaces that we have used to implement this project is the first is LED. As we all know, LED is nothing but light emitting diodes. They are semiconductor device that emit light when an electric current passes through them. LEDs consist of semiconductor chip mounted on a reflective material and then encapsulated in a transparent lens to protect the chip and focus the light. The semiconductor chip is typically made of gallium arsenide, gallium phosphide, or gallium nitride, which determines the color of the emitting light. So in the diagram we could see we have cathode, diode, P layer, active region, N layer, substrate, and anode. And we have a plastic transparent case or the lens. So the second interface which we have used is CLCD. Generally we know LCD, that is liquid crystal display. Here CLCD stands for character LCD, which refers to a type of LCD, that is liquid crystal display, that is commonly used to display characters and symbols. Character LCDs consist of a grid of pixels arranged in rows and columns. Each pixels can be turned off and on, allowing it to display a specific character or symbol. They come in different sizes, example 16 cross 2, 20 cross 4, indicating the number of characters and lines they can display. To use a character, LCD, you typically need to connect it to a microcontroller or other devices using a communication protocols such as I2C or SPI. Character LCDs are popular in various applications such as electronic devices, appliances, and industrial equipments due to their low cost, simplicity, and readability. In CLCD, we have totally 16 pins, and we have the specifications over here. The pin 1 and pin 2 are for VDD, pin 3 is for V0, pin 4 is for RS, pin 5 is for RW, that is read write operation, 6 is for E, and pins 7 to 14 are data pins, that is D0 to D7. Pin 15 is A and pin 16 is K, that is anode and cathode. So the third is the tactile switch. A tactile switch, also known as a tactile button or a tactile dome switch, is a type of momentary push button switch. These switches are commonly used in electronic and electrical devices where a user interface is required, such as keyboard, keypads, and control panels. Tactile switches are characterized by their tactile feel, which is a distinct mechanical feedback felt by the user when the switch actuates. This feedback is achieved through the use of a dome shaped metal rubber contact inside the switch that collapses and then rebounds when the button is pressed and released, respectively. Here we could see the structure of the tactile switch. Here we have the overlay, the metal dome, conductive track, and a substrate. So the fourth peripheral is fan. A fan is a key component of many electronic devices and systems designed to provide active cooling by moving air. Fans are typically small, lightweight, and power efficient, making them ideal for integration into devices where space and energy consumption are critical consideration. These fans are commonly used in various applications, including computers, servers, automotive electronics, and industrial equipments. The fan's speed operation are often controlled by a microcontroller. So the fifth component or the peripheral we are using here is buzzer. Buzzer are small electromechanical components that are designed to convert electrical signal into a sound wave. Typically, buzzer consists of a coil and which vibrates to produce sound when an altering current is applied. The common configuration for a simple buzzer includes two pins, one for the positive connection, that is VCC, and one for the negative connection, ground. When connected to a microcontroller or other control circuit, the buzzer can be activated by applying a digital signal high to positive pin while keeping the negative pin connected to ground. So next is the timer. Timers in microcontroller are versatile hardware modules used for measuring time intervals, generating precise timing signals, and implementing time critical operations. In the microcontroller which we are using has three independent timers built in that microcontroller. Those are timer 0, timer 1, and timer 2. So timer 0 is a 8-bit timer, timer 1 is a versatile 16-bit timer, timer 2 is a 8-bit timer with prescaler and postscalers. So moving ahead with the software tools used to implement a washing machine simulator is MPLAB X IDE. MPLAB X IDE is a integrated developed environment, that is IDE, created by Microchip Technology for developing applications for microchip microcontroller and digital signal controllers. It is a powerful tool that provides a comprehensive development environment for embedded system developers. So some key features of this software tools are code editor, program management, sorry, project management, debugger, simulator, device support, plugin support. The second is PIC Lab is a software simulation tool for PIC microcontrollers developed by Neutronic Soft. It allows developers to simulate and debug PIC microcontroller programs without the need for actual hardware. PiximLab provides a virtual environment where user can write, test, and debug their PIC assembly or C language codes. Some features of this includes simulation environment, code editor, debugger, peripheral simulation, virtual oscilloscope. So, so the second software is PiximLab. PiximLab is a software simulation tool for PIC microcontrollers developed by Neutronic Soft. It allows developer to simulate a debug PIC microcontroller programs without the need of actual hardware. PiximLab provides a virtual environment where user can write, test, and debug their PIC assembly or C language code. Some features of this includes simulation environment, code editor, debugger, peripheral simulation, virtual oscilloscope, support for different PIC models. So the third software is XC8 compiler. XC8 is a compiler for the microchip PIC microcontroller family. It is a part of a MPLAB XC compiler family, which includes compiler for various microchip microcontroller family, such as PIC, AVR, and ARM. Key features of this are C standard compilance, optimization, peripherals, libraries, integration with MPLAB X IDE, support for different PIC families. So moving ahead with the functional requirement for interfacing our projects. So we are using four switches, switch 5 for power on, switch 6 for pause and stop, switch 4 for navigation, switch 1 for door status. And here we are using a CLCD, that is to display the washing status, a buzzer, and a motor. So these are the six descriptions. So first one is power on screen description. So in first description, uh, as soon as board is reset, print press key 5 to power on washing machine on CLCD. Wait till SW5 is pressed. If switch 5 is pressed, print powering on washing machine. So the second requirement is washing program screen description. The washing program screen description, so it provides a menu, that is a menu that contain the following washing options, that is daily, heavy, delicate, white, stain wash, eco cotton, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua stores. Using the keypad SW4, we can scroll between the options available. A long press on SW4 will select the option highlighted with the asterisk symbol. So the third requirement is water level screen description. This screen should allow the user to select water level. The water level menu will contain the following displays. So those are auto, low, medium, high. Low, using the keypad SW4, we can scroll between the options available. A long press on SW4 will select the option highlighted with asterisk. Start screen description. So the fourth requirement is the start screen description. Once washing program and water level is selected, provide user option to start the machine. If SW5 is pressed, start the machine. Display the function selected and time taken. Then switch to the function screen. The fifth requirement is function screen description. Once machine started, display the function ongoing. It can be wash, rinse, or spin. Along with display the time left on the LCD. So the fifth requirement is function screen description. once machine started, display the function ongoing. It can be wash, rinse or spin. Along with the display, the time left on the CLCD. So the fifth requirement is complete status screen description. Once all programs are completed, display notification that program completed, remove clothes on CLCD. So now we are going to see a demo of the implemented washing machine simulator. So this is the PIC16F877A microcontroller. We have to select PIC Genius. Then we have to load the code. So now we have uploaded the code to the microcontroller. We have to reset. So here we could say CLCD press key 5 to power on the washing machine. So when we press key 5, the washing machine door is on. So here we could see washing program, daily, heavy, whites. So we can navigate through it by using switch 4, and we have watching programs. Many options we have here as I've specified before in the PPT. So by pressing the switch 4 for a longer time, then the particular option is selected. So here we could see the water level, auto, low, in the medium, high. So we have various options to select the water level. So we are pressing switch 4 for a longer time to select the option. So here we could see we could see in display that press switch SW5 start, here stop. So here we could see the function of watch time is on. So if we press switch 6, the fan stops and the function wash is stopped. We could see the time has been halted. So to start the program or to continue, we have to press switch 5. So this indicates that the clothes are washing now. So we have set few seconds of timer. We have to wait until the timer is completed. So when the time comes down to 0, the washing machine automatically stops. So here it comes to the first requirement. Second requirement, that is washing program. So finally, the conclusion. In conclusion, the washing machine simulator project successfully achieved its goal of developing a interactive interface for a washing machine using the PIC16F877A microcontroller. The project allows user to select various washing modes and water level, with the interface displaying the current function and remaining time. This project demonstrates the application of embedded system in creating user-friendly interfaces for everyday appliances, showcasing the versatile and practicality of microcontroller based system in real world scenarios. Thank you.